We aren't afraid of taking risks or doing what no one else is doing. We are a group of great people doing great things. Innovation, empowerment, sustainability, partnerships, perseverance. This is all part of our DNA. Since 1988, we have been pioneering a new way in HVAC solutions, and we want to share our stories with you. Expect a diverse range of episodes, from technical deep dives to uplifting stories, along with insightful discussions about the HVAC industry landscape as we see it at AAON. This is a deeper look inside AAON.
Welcome everyone to Inside AAON. This is Derby, your host for today. Today is actually our first episode. Yay! We are super excited to be here and very grateful for the opportunity to have this channel to connect with our customers, with our employees, with the industry as a whole. So with that, I'm going to introduce to my co-host. She's Whitney Tapp, the amazing Whitney Tapp, here to keep me out of trouble and on track.
I'll do my best.
Whitney, say hi.
Hi.
And to my right, we have a subject expert, and that is Kevin Teakell, or should I say the Kevin Teakell. He is an expert on the industry landscape. He talks around the country about the subject. So, Kevin, thank you so much for being here.
Glad I could be here. Hopefully we can get some stuff straightened out here.
I'm sure we will. Well, as we know, and the audience knows very well, we're going through a refrigerant transition, a lot of regulation changes, and that is exactly what this episode is about. So I just simply want to start with, what do you do at AAON today?
Well, so the big thing these days, of course, is all this regulatory stuff that's happening to us, right? So I head up government affairs for AAON, both, any of the government stuff from regulatory to state actions, federal, all the kinds of stuff. So, and there's a lot of it happening, right? So that's, my days are pretty much filled with conference calls, talking to various whoever about all these different regulations, anywhere from chemicals to refrigerants to product efficiency, you name it. So it just kind of covers it all.
I can imagine, to keep track of all of it. So, depending what your age is and which generations you are, this might be the first time that you're experiencing a refrigerant transition. It is mine, at least in my adult career.
Same.
How about yourself?
Yeah.
Yeah. So, but I know that you have been through a couple of these. Could you tell us a little bit, how do they compare? I know the latest one was 410A. How did that transition go compared to the one today?
Yeah, so 410A, the official transition date for that was January 1st, 2010. So at AAON, we actually had been developing product with 410A all the way back in the late 90s. We had some customers that actually wanted it all the way back then because it was going to be the next refrigerant. It was very certain, that refrigerant transition was very certain for the entire industry. We really knew what we were going to do. The only problem with it was that it was a lot higher pressure. It was about 50% higher pressure than what we were used to. But as far as as our customers and engineers and such, nothing really changed for them. We had to make our products be able to withstand the pressures, but for them, not much changed. So that was, the first one I really went through in a big way. And then, of course, we're now on this next transition. Now, this transition is a lot different in that it's really much more safety driven, because now our refrigerants are in this mildly flammable category. Building codes have to change to be able to use these refrigerants. So it's an entire industry-wide transition, whereas the last one really had more to do just with the manufacturers making sure the products could withstand the pressures. So to me, that's really the big difference here. We've got a lot more people that have to understand what's going on in this transition to make it work.
It sounds like the previous transition maybe affected less the public and more the manufacturer, and this one is really affecting both parties.
I would definitely agree with that. Yep.
Okay, perfect. Who starts this? Where does the transition idea and why? Where does this originate?
Yeah, so I guess we can take a little bit of a history lesson here. This really kind of started in the late 80s. Okay, so in the late 80s, they started to get very concerned about ozone depleting substances. And they determined that like R22, which is what we were using in air conditioning, was an ozone depleting substance. Okay, so it was a UN treaty. Pretty much all the countries in the world wind up signing it. And then as we kind of got into the 2010s and so, shortly after we just switched to new refrigerants, they start started to be worried about global warming potential of the refrigerants. So then an amendment was kind of started to the Montreal Protocol, known as the Kigali Amendment. Okay, so it was it kind of started to get steam around, I don't know, 2015, something like that. Various countries in the world started to ratify it, and it was really targeted to reduce the global warming potential of any refrigerants and other gases that we use. So that's kind of how we got to where we are now. And that's the two different refrigerant transitions. Really, the first one was ozone depleting. The second one was global warming potential.
Just a change in terminology. It's still the same goal of protecting the globe.
Yeah, two different metrics, but yeah.
Okay, excellent. So it's not secret that AAON has already selected its refrigerant.
Yeah, we released, a lot of information about what we chose, I don't know, a couple of years ago, R454B. So that's our chosen refrigerant to replace 410A.
Could you tell us a little bit about why 454B versus R32 is the other option?
Yeah, so when you look at air conditioning, there's kind of two major replacement possibilities for the refrigerant. So it came down to R32 and R454B. So in general, they're pretty similar to 410A. 454B is actually a lot closer. So it performs very similar to 410A. And that's really one of the drivers why we chose it. So as we're going through this transition, really the big thing about it is the flammable, it's a mildly flammable refrigerant. So our safety standards that are used to certify the safety of our equipment, it all had to be rewritten. So it's all new safety standards. So as this was happening, we had to go through and determine, the pros and cons of each of these refrigerants. 454B performs much more similar to 410A. So our existing equipment didn't need as many modifications as if we'd gone with R32, there'd been a lot more redesign work we would have to perform. So we're already doing a lot of safety stuff. So that's a good reason for staying with 454B, just because it not as much redesign required. But even more importantly, right, is the GWP, right, the global warming potential refrigerant. So that's the whole name of the game here, is to get to the lowest value we can get. Well, R32 has about 667 GWP, whereas 454B is about 467. So R32 is about 50% higher GWP than 454B. So really, to us, the name of the game, right, is get as low as we can go. So let's go with a refrigerant that gets us to those goals. So that's, a couple of reasons why we decided to go 454B. Most of the manufacturers in North America that make air conditioning have also decided on 454B. There's a few that have gone with R32, but in general, the vast majority of the industry has decided 454B.
Excellent. You mentioned flammability a couple of times, and that's not a word that we like, right?
Yeah, it makes me a little nervous. So is AAON doing anything about the safety side of this new?
Yeah,
refrigerant?
so, that's been our big driving force on this, is to make this safe, okay? So the industry's been working with these refrigerants for at least a decade.
Okay,
and there's been millions of dollars of research that the industry as a whole has done between ASHRAE, HRI, individual companies. Lots of research has been done into this. Like I said earlier, we completely rewrote all of our safety standards that we use to build and evaluate our products. So we've gone through a lot of processes to make sure this is safe. So when you look at the refrigerant classifications, okay, there's kind of two digits that are typically known, and this is important because you'll hear these terms a lot, but there's kind of two digits that are thrown around. The first digit refers to the flammability, to the toxicity. It's either A or B, meaning if it's A, it's non-toxic. If it's B, it's toxic. And then the second digit is flammability. It's either 1, 2, or 3. So 1 is non-flammable, 2 is flammable, and 3 is very flammable, okay? So currently today, 410A is an A1. So it's non-toxic, non-flammable. These new refrigerants, though, as they started to do more research on them, they found that they weren't as flammable as even an A2, okay? So if you use, there's not many refrigerants that are a 2, but if you used a 2, the charge limitations would be very low. So you wouldn't be able to use very much charge. You wouldn't be able to have very large air conditioning systems. So they came up with this new category known as A2L, or lower flammability limit. Okay. So you'll hear this term a lot, A2L. We talk about it all the time. It's one of the big things you'll hear when we talk about these new refrigerants. It's an A2L. So this lower flammability, there's several requirements to fall into this. One of them is the flame has to move less than 4 inches per second. Okay, so it's a very slow moving flame. It's pretty hard to light it. So when you think flammability, you may think propane or natural gas.
Sure, that's what I was thinking as soon as you say flammable.
Right.
Propane.
So, propane is actually a refrigerant. It's actually a refrigerant many companies are looking into in the future. But propane's an A3. So it's non-toxic, but it's very flammable, right? We understand how flammable propane is by our propane grill, right?
Yeah.
Sure. So it's very flammable, and in many instances, it's actually kind of deemed to be explosive. Well, these refrigerants are nothing like that. Okay, like I said, 4 inches per second, which is very slow. It's very hard to light. So, like things like a spark, right, that you might have from a contact or a relay or something like that. There's not enough energy in that to actually usually ever ignite one of these A2L refrigerants. And they also they're not explosive. They tend to extinguish themselves after a little bit. So it's kind of hard to light, kind of hard to keep lit. But it does require some respect, right?
Sure.
It does have some flammable properties. There are certain instances where industry's been able to get like the right set of conditions and get some pretty good flame to develop. So it is something to be respected, but probably not something to be feared.
Okay, that's good to hear.
We've been dealing with natural gas for 100 years, right, in furnaces. And natural gas is far more flammable than any of these new refrigerants are. And we don't have near the safeties that we have for a gas leak, like a natural gas leak, compared to the safeties that we're putting in this new equipment. So,
yeah, I witnessed in the lab at AAON how they tried to light up the R454B, and it wasn't only exposure to the fire. It had to be the exposure for a period of time. And then almost as soon as the exposure to fire went away, it quickly diminished.
Yeah, like I said, it's kind of hard to light and it's kind of hard to keep lit. So
yeah. So you mentioned that there are additional safety features for this refrigerant. I imagine like sensors or something.
Yeah. So our new safety standards require us to do testing. Okay. And our testing requires, in most applications, even all the way down to residential equipment, you're going to wind up seeing refrigerant leak detectors. Okay, so these leak detectors, they have to go in strategic places in the equipment, and the idea is if it ever senses a leak, okay, we go through a little sequence, right? So the sequence is if we sense a leak, we have to shut off the compressor, we have to turn on the supply fan to move air, right? Because the dilution is the solution to pollution, okay? The old term.
I like that.
So you move a lot of air so that you reduce the effective volume or the percentage of volume that you have of this refrigerant. And then we also sound an alarm. So we close an alarm contact to notify the building we've sensed a refrigerant leak. And then once the compressor's off, so it's not building pressure and things like that. So our safety standards require us to go through and do testing on all of our different pieces of equipment we make and verify that we've got these detectors in the right location.
Yeah.
So we're probably going to have to require that smoke detectors are not mounted in the unit.
Okay.
We're still kind of working through some of those details. But yeah, sometimes the refrigerants can cause a false smoke detector reading with the current smoke detector technology. So there's some things that are still being worked out there.
Okay.
Well, in the sequence of operation that you would implement if it was smoke versus refrigerant, it will be almost exactly the opposite.
It kind of depends on the building. With smoke detection, some buildings will, and it depends on where the unit is in the building. Mm-hmm. If there's smoke detected in that particular zone, they'll usually shut off the fan to that zone so that they're not feeding oxygen. But in other zones, they may feed fans and exhaust and try to do more to try to evacuate smoke from other areas.
Purge.
So it really depends on the building as how they do smoke purge. But with the refrigerant leak, we've got very defined procedures that everyone has to follow for that.
Okay. So considering that if there is a refrigerant leak, you would be pushing this to the space. I heard, is there like any regulations when it comes to how much space these one unit should be feeding into?
Yeah, so there's requirements in the safety standards, both the building codes and our appliance safety standards, where it defines for a given charge how much area that unit can serve. Okay, so there's the design engineer in the field is going to have to, when they're designing a building and they're looking at all their various spaces, they have to look at, what space a particular air conditioner is serving, and then they have to look at the charge of that unit, and then they have to do some calculations to figure out, can that much charge go in that room safely? So there's standards in ASHRAE 15 as well as our appliance safety standard, which is UL 60335-2-40. A lot of numbers there. But those safety standards prescribe how you do those calculations.
Okay.
So that's the minimum square footage that you'll see stamped on like those window units now. I noticed a new thing when I went and had to buy one. I was like, what's this?
That's what it is. I
was like, 430 square feet, what?
Yeah, and we have to put that on our unit nameplates as well.
Wow.
So is the manufacturer responsibility to communicate the square footage, but is the engineer responsibility to apply it correctly?
Right, and unfortunately at this point, so the design engineer for the building, they're using ASHRAE 15. Okay, for the safety standards and their building codes and all that, and our equipment safety standard, which is the 60335, is they're kind of out of sequence at the moment. So their calculations are slightly different. So we may give you one calculation, and the building engineer may calculate a slightly different one. Ours is, I think, a little more conservative at this point. So it's their calculations may say you could serve a little bigger space than maybe our nameplate will say. And our nameplate also, in our safety standard, we're kind of required to make some certain assumptions, whereas when they're doing it for the building, they're actually taking into account a lot of different things about the height of the space and where windows are and various things. So it will look a little different maybe what we put on the nameplate versus what maybe the field engineer calculates, but. I anticipate over time those standards will get a little more aligned. The thing about standards always is one standard has a 3-year cycle, and the other one may have a 4 or 5, and they get out of sequence, and they're always trying to play catch up. So sometimes there's differences, but
it's just a lot, and the regulation comes from the federal government or the treaties. But then the implementation is up to the different states or provinces in the case of Canada. Right. Could you share with us a little bit, are the states and the province pretty uniform on how they are implementing these? Okay,
so as we've developed these new refrigerants, right, we talked about A2L, and they're now mildly flammable. The unfortunate part was it's kind of a new category. I mean, it technically existed, but nobody ever really recognized it. So now we're in this situation where the building codes don't recognize these new fluids we're using. So
that
now,
like a problem.
Exactly. So we're going to be required. I'm sure we'll get into dates here in a little bit, but we'll be required here by the end of the year to be producing equipment with these new refrigerants. But the building codes don't yet recognize these new refrigerants. So a different process has kind of had to been implemented to get some adoption here. So some states have the ability to just go into their building code and make some modifications that can accept these new refrigerants. The majority of states don't really have that ability. So what we've done as an industry is we've gone to all these different individual states, and we've passed legislation that allows the use of these refrigerants. So it's been a very long process. The industry's put a lot of effort into doing this, going to all 50 states to make sure to get the building codes all done, because the A2Ls will make it into the national model building codes like IBC and IAPMO probably by the end of this year. But it takes a long time to update building codes. Like here in Oklahoma, our building code's, I think, over 10 years old. And that happens a lot in various states. There's a handful of states that will update building codes as soon as they come out, but most states, they don't unless they see a need. So it can take years to decades sometimes to update building codes. And of course, we don't have that kind of time. So we had to go individually, state by state. Some places we have to go city by city because some states they have rules that certain cities can have their own building codes. So it's a big mess kind of to get through all this.
That's a tough job.
And we've as an industry, through our industry leadership and stuff, a lot has happened. We're very close. We just have a couple of states that we're still kind of worried about. If you're in Michigan or Massachusetts, we need some help to get you through the finish line here. They're struggling to get done there.
So that takes me to the next question perfectly. What is What are things that individual within our industry that want to do something about this can do?
Yeah, so with ASHRAE, ASHRAE is, and I think we'll probably talk about maybe some of these different organizations here in a little while, but like with ASHRAE, ASHRAE is kind of the industry association of engineers, individuals, okay, and these, through ASHRAE chapters. So most cities have a local ASHRAE chapter. What's happened a lot is a lot of these ASHRAE chapters have gone to their capital and lobbied their legislatures to accept these refrigerants. That's what happened here in Oklahoma. Our local ASHRAE chapter went and got that done. So if you're an engineer and you're in ASHRAE and you're in one of these places that's struggling to get this done, get involved through ASHRAE. ASHRAE can help get this done. But we also we know people throughout industry, our sales reps and customers, various people that know politicians, right? Yeah. Of course, right? They know politicians. You can get their, if you have their ear, that's a great resource to
get their attention
and get their attention and tell them how big a problem this is.
Yes.
So there's multiple ways you can get involved. Letter writing, just different things. But those are some of the ways.
Yeah, I mean, it's a huge matter. We won't be able to supply in this industry a state or a province that doesn't go through these regulations.
Right. Like right now, Michigan and Massachusetts, if they don't get this done, we will not be able to ship air conditioning into those states at the beginning of next year. So this has to get done. So
what about Canada?
Yeah, so Canada is kind of a different process, of course. So in Canada, they have, in the United States, we use ASHRAE 15 as our safety standard. And that gets, we use ASHRAE 15 and it goes into the building codes to get them updated. So in Canada, they use what's known as B52. It's basically the same thing as ASHRAE 15. So B52 was just published at the end of last year. So it's just now getting done. So we're now kind of in a scramble to get all of the various provinces in Canada to update to the newest building code. Now, several of the provinces in Canada automatically update. So it may take less than 6 months to update, and once they've adopted B52, then they can use these refrigerants. But there's several provinces that don't auto update and that can take time. Now some of the larger ones the industry's been working with and trying to explain this, and they're acting kind of like they're hoping to be done by the end of the year. We're going to see.
Hoping. Yeah.
So there's some hope. There's a lot of work going into it. I encourage our Canadian friends, if you're in one of these provinces, that if you know people in the legislature or ASHRAE chapters, all the same things we just talked about, get involved, because what's going to happen here is by the end of this year, the EPA won't allow us to make any. After this year, we won't be able to make any more 410A products, even for export. So if Canada doesn't allow these refrigerants, we won't be able to ship something to Canada.
Well, I think it's great to point out that you may be a little intimidated to just go to your local authority and talk about these. So reach out to us. We have Kevin Teakell, and I will volunteer him to help you on how to talk to people about and educate them on what matters here.
Yeah, it's important to remember, too, if you go talk to these folks, you're going to be the expert on this, right? Yeah. And you don't have to know every little detail.
Exactly.
You just kind of have to know a few things.
Yeah.
And you can really help them out, and you can help your business out, of course, because you want to sell air conditioners. But you're going to help out all the people in your province as well, too, right?
Well, and the reality is that you want to get their attention and make them realize that this is a problem, and then they can do the research themselves and call the Kevin Teakells of the world.
Yeah.
And others. Wow. We talked a lot about safety, and I'm sure you're very interested in the
transportation side of it. Yeah. So I have a husband that works in shipping at AAON, and I know they're all kind of questioning how are they going to ship out this equipment with the new classification. I assume like hazmat regulations might be involved, or
yeah. So at the same time, we're working on the whole building code side of things. We've got to work on transportation too, right? We've got to get it from our plant to your job site. So. The U.S. Department of Transportation is involved in this side of it. So it's not the building codes, it's DOT. So the DOT didn't ever have rules for transporting A2L refrigerants either. So, they had rules for transporting A2s or A3s, but those were very strict. They're determined to be, hazardous materials, very small charges, it can be placards and special routes and hazmat drivers and all these kinds of things. Well, we're a very large industry. We ship millions of units every year. The the practicality of making everything hazmat would just be impossible to deal with.
And unnecessary.
And yes.
That would be a mess.
And unnecessary. So industry has worked with U.S. Department of Transportation to try to adopt some new rules that recognize these new refrigerants. And that's a long process to get that done, and they're not quite ready for that yet. But what they've agreed to do is there's a couple of industry permits that they've developed, and we've signed on to these permits. And what these permits do is it allows us to ship these products. There's kind of two different permits we have to be a part of. One is for any equipment that has less than 44 pounds of refrigerant charge, and then the other one is for anything with 44 to 5,000 pounds of refrigerant. So any of our bigger equipment. Anything below 44 pounds is essentially a complete exemption from any hazmat regulations. Okay, so any of the hazmat stuff we would have done, we don't have to do it all. Okay. So we just have to have that permit with us when we ship the equipment. So it has to stay with the equipment throughout its shipping, from our factory to the job site.
Yeah.
But sometimes it may go to a rigger's yard, right?
Yep.
Or freight
storage
yard
or something.
Yeah.
It may go to one of those places for a while. So that permit needs to be with it when it goes from that rigger yard to the actual job site. Okay.
With it and accessible, or it has to be in the cabinet?
Well, we're going to be putting it in the cabinet, so you'll be able to open the main control panel door and get to it. We'll also have them in the plant, so if it got lost and you ran into trouble or something, you could get a hold of us and get you one. One of the stipulations is if there's ever an accident where refrigerant is leaked, it has to be reported to DOT. You can't do things like this equipment, anything less than 44 pounds, it can't fly in aircraft, no air transport, it has to be, kind of open containers and stuff. The equipment that's from 44 to 5,000 pounds, it has a little extra rules to it. It wasn't a complete exemption of the hazmat rules. So we do have to label these products. So we have to put it's a flammable sticker we'll be putting on a couple of sides of the unit. It's like a 4-inch by 4-inch sticker. So we have to put that on there. You can't ship these by water or rail. They have to all be open trailers. So there's a few differences. You don't have to, normally with hazmat, you'd have to have placards on the truck too. And in this case, you don't have to have placards on the truck. You don't have to have special hazmat drivers or any of that kind of stuff. So some differences between the two, but in general, very similar.
Great.
But that does, allows us to ship stuff.
Yeah.
I'm curious. When I think of new regulation, I always think that they come with some sort of cost. It costs somebody to do this. I'm particularly interested in the performance. Is there a huge cost in performance due to the new refrigerant?
So, we've done a lot of testing on equipment, and we did this even before we made our final decision. But what we're seeing between 454B and 410A is it depends on the product. It's usually within 1 or 2% of efficiency and capacity.
Wow.
It could be plus or minus 1 or 2%. It kind of depends on the unit, but in general, it's almost identical to what you're used to seeing with 410A. So, from a performance capacity standpoint, really hardly any noticeable difference at all.
Good to know.
So there was something I was very interested in asking you today with this transition, something that's been getting a lot of buzz in the industry, and that is sell-through dates. I understand that was like a new addition to the rule that was added. How is that going to affect AAON?
Yeah, so the EPA rule that came out, which is governing our dates, right? So they're going to require our GWP to be less than 700 for any products that we make beginning 1/1/25. So, we're just a little over 10 months away from this happening.
The clock's ticking.
Yeah.
Right, the clock's ticking on us. So when we think about, as AAON, when we think about making a product and shipping a product, to us, that's kind of the same thing. At AAON, we build our equipment specifically for our customer. Everything's built to order. So, most of the industry will build products with a few options, and then they may have a lot of add-on kits or various things.
So like a very cookie cutter style every time. Yeah,
very cookie cutter.
Okay.
They kind of, I like to say, they kind of make the customer finish building the uniform. But we don't do that. Everything we build is build to order. So to us, the ship date is the same thing as the build date. Yeah. But with this rule that EPA passed, they're requiring us to have everything built by the end of this year, anything with R410A. So we can't build anything with R410A after this year. But what they do is they don't want to strand inventory. Okay, so as we talk about most of the industry's business model, they build a lot of stock and then they sell it right through distributors over time. So EPA didn't want to strand any inventory, so they're allowing the industry to build as many units as you want this year, and then they're giving the industry 3 years to sell that. Okay, so as long as it's built by the end of this year, you've got 3 years to get it sold. And that's kind of what's considered to be the sell-through period.
Okay.
So you will hear that term thrown around, but like I said, the AAON, the build date is kind of the same as our ship date because we build everything to order.
Yeah.
Yeah. I love that. I love that DNA of our company that we build product for our customers instead of finding customers for a product.
Yeah.
I don't know if you
Yeah,
think
that's a good way to put it.
exactly.
Yeah.
I like the way you said that.
Yeah. Awesome. Well, this is a fascinating topic. I'm sure we could talk about these for hours, and you do.
I do talk about it a lot. Probably bore people to death, but it's important information.
I am so glad it's you who's doing this. But for our audience and for ourselves too, there's so many terminology and things. So we prepare two things for you.
Okay.
We have some terminology that we want you to let us know what it means.
Okay.
And then also we have a few questions done as a ping pong style if you want to answer to us.
All right. Hopefully I can manage to answer.
All right. So starting with the terminology.
You cannot say pass.
No pass.
It's not that game.
Pass.
Can I call a friend?
You could call a friend,
Okay.
yes.
All right.
Okay. So starting with the terminology. So A2L, what is that exactly?
Okay. So that's the safety classification for these new refrigerants we kind of talked about earlier. The A means non-toxic. The 2 means flammable, and the L means lower flammable. So it's lower flammability, but still flammable, but non-toxic.
All right. Now GWP.
So GWP stands for global warming potential, and that's always kind of reference to CO2. CO2 has a GWP of 1, and then everything else is a multiple of that.
Another one is DOE. I imagine that's not a female deer.
Yeah, so the DOE stands for the U.S. Department of Energy. So they're the ones that set all of our energy efficiency regulations.
Okay.
They do everything from your washer machine to your clothes dryers to commercial air conditioning to ice makers, you name it. So they've got lots of categories where they determine the minimum efficiency for a product, and they have what's known as preemption, which says that if the U.S. Department of Energy says the minimum efficiency is this, no state can go higher and no state can go lower than that. Okay, so they've got pretty specific legal authority that gives them the ability to set these minimum efficiencies.
Okay. EPA.
So that's the Environmental Protection Agency for the U.S. government. So EPA and DOE they're kind of separate things, but in general, for our industry, kind of some of the same things. So when we're talking efficiency for products, that's DOE. When we're talking things like refrigerants, that's the EPA. So they're regulating the GWP. They're the ones that are kind of implementing. We didn't talk about it much, but the what's known as the AIM Act, which gave the EPA the authority to regulate refrigerants based on GWP. They didn't have that before. It's interesting. During the Obama administration, they tried to do some regulations based on GWP, and the Supreme Court ruled that they didn't have that authority. So before Kigali got ratified in the U.S., industry worked with U.S. Congress to develop what was known as the AIM Act, and that gave the EPA the authority to regulate refrigerants based on GWP, and Trump signed that into law towards the end of his administration. So, and the AIM Act followed the Kigali Amendment. So it's the same phase down schedule that's in Kigali. So it gave the industry the certainty we needed to be able to make products for the entire country. Without that authority, it was going to kind of be, some states would go with this GWP and some would be different, and it'd be very hard for the industry to manage. So, but the EPA in general covers things like air and water, how clean air is, water, all the environmental regulations come through the EPA.
Okay. And then the last is ASHRAE and AHRI.
All right. So ASHRAE, they've kind of rebranded themselves, but it's still ASHRAE, but it used to be the American Society of Heating, Refrigeration, and Air Conditioning Engineers. But ASHRAE, and now they just call themselves ASHRAE because they want to be more international. But ASHRAE is an association of engineers from this industry. Okay, so I'm a member of ASHRAE as myself. Okay, and there's tens of thousands of engineers that are members of ASHRAE. With ASHRAE, we pay our own memberships now. AAON and many companies will pay for their engineers to be a member. AAON pays for all my expenses to go to ASHRAE because we see the benefit in that. But ASHRAE is an engineer organization. It's an association of engineers in this industry. AHRI is the Air Conditioning, Heating, Refrigeration Institute, and it's an industry trade association. So companies like AAON is a member of AHRI. So that's kind of the difference. It's AHRI is companies, ASHRAE is engineers.
And AHRI is where you can go to the directory and get those.
Yeah, so AHRI, it's our industry association, and really one of the biggest things AHRI is known for is its third-party certification. Okay, third-party certification is really important because it's a third party that goes through and tests everybody's equipment every year. They test 20% of our basic models every year, to verify what our capacity, our efficiency, to verify what we say is what we actually do.
Yeah.
Okay. So, and not everyone in the industry is part of AHRI, but that certification is really important. So you've got that third party compliance that says, hey, yeah, they do what they say they do.
Yeah.
Okay. R454B with a GWP of
467.
Okay. Okay. So how does that compare to R32?
R32 is about 667. So R32 is about 50% higher GWP than R454B.
Okay. My other question is, it's you that you're so into the regulations and paying attention to everything that is going on. Do you have any prediction of where we're going with GWP?
That's a difficult question. We're always trying to answer that one, right? What's our next step, right? Of course, we haven't even started this new transition yet, right? We're just now starting to build equipment for it, but everyone wants to know what's the next one. But we are, we're trying to figure that out. If you force me to say something, I'm going to say it's maybe 2034. Okay. Just that would align with some of the Kigali phase down. And if I had to guess on a GWP, I'd say 150 for air conditioning. But I mean, I don't have anything to go off of other than just gut feel at this point. So, there's been groups that have said we need to be below 500 in 2029. If we had to do that, R32 would be out, and we would still be fine with 454B. Okay. I don't really expect that to happen at this point, but I mean, it's possible. The other thing that's unfortunate, right? I mentioned earlier that with DOE, they've got preemption on efficiency standards. Well, with the AIM Act and the EPA, unfortunately we weren't able to get preemption for the GWP of refrigerants. So the EPA now has the authority to set the maximum GWP, which is what they've done, right? With 125, we have to be less than 700. But it doesn't prevent states from going lower. So you've got some more of your, more progressive states, like California, Washington State, that have proposed going much lower. Okay. New York State has got a very serious reduction they're proposing at the moment. So states can go much lower on GWP, and that may drive the industry. It just kind of depends what winds up happening.
Well, it will be interesting to see how the manufacturers react to it too.
Right.
Yeah, exactly. Yeah. So here are those ping pong rapid fire questions you mentioned earlier. Can R454B be used as a drop-in refrigerant in place of 410A?
So it will be completely illegal. Okay.
So don't do it, Derby.
You are not allowed to. You are not allowed to put 454B into an existing 410A system. Okay. That's because that 410A system was never certified under our new safety standard. It doesn't have those refrigerant leak detectors.
Okay.
So it would be completely illegal to put 454B into an existing 410A unit.
Okay. You heard it. Don't do it. Next, we got, should technicians be intimidated by the flammability aspect?
We kind of talked about this a little bit earlier. I wouldn't say intimidated, but be respectful, right? This is there's some hazards with it. If you get just the right set of circumstances, there's going to be a bunch of new rules probably for techs. Some of those things are still being developed by EPA, but some things we do know we're going to have to. Techs will no longer be able to braze on a system with refrigerant charged in it. You really shouldn't have ever done that anyway.
Yeah,
But
I mean, I've seen some do it.
I think it probably happens. But with an A2L refrigerant, you must evacuate that system before you braze on it with a torch. You have to evacuate the system. You have to actually flush it with an inert gas, so like nitrogen, just to make sure there's none in there when you go to light up that system. There's going to be leak tests and pressure tests that are required. So there's definitely some things techs are going to have to do. Like I said, a lot of the rules are still being written about, leak testing versus the size of the system and things like that. But like in their truck, they're probably going to have to, if they've ever stored their refrigerant bottles in horizontal, they're not going to be able to do that anymore. They're going to have to be in a vertical arrangement. So there's different things that are coming. At one point they were talking about you need spark-free tools. Well, they've kind of said that's not really the case anymore. Another question we get from techs a lot is, am I going to have to get recertified for my 608 certification, which is what allows a tech to put refrigerant in and out of a unit. And at this point, EPA hasn't done anything on that. They've been asking questions, so they've got a public rule out at the moment asking some questions. Are there some different things we should do for techs? So those comments are due here in a few weeks. So we'll have to see what comments they get back and whether EPA decides to change the technician training or not.
Yeah.
So still a bunch of open things for the tech side. So if you're a tech, you need to be paying attention. And unfortunately, I talked to a lot of folks, and a lot of people don't really know these dates or what's coming. They may have heard that something's happening, but they don't know how imminent it really is.
Yeah. And that is my next question. What are some of the deadlines we need to keep in mind with this transition?
All right. So the deadlines are pretty important. So for the United States, the EPA has a rule that they finalized in October last year, which says that for air conditioning, residential, commercial air conditioning, our GWP has to be less than 700 beginning 1/1/25 for any products that are built. Okay, so we've got till the end of this year to get anything with 410A done. There's a lot of different, depending on the product type, commercial refrigeration, there's a lot of different requirements based on the application. AAON, we're concerned about commercial air conditioning, so that's what I'll talk about. But VRF got an extra year, so VRF systems will have until they can be made up until 1/1/26.
Okay.
Awesome. Well, thank you so much. There is a way that we like to finish every podcast, and that is to ask our guest of honor, what is AAON to you?
Well, when you say every podcast, since this is the first one, I guess what AAON means to me, I've worked at AAON, it's almost 28 years now. So I guess I've had more good days than bad, right? Mm-hmm. But AAON's been a pretty special place. When I started AAON, it was kind of, I don't know, kind of chaotic maybe. And I guess I learned to enjoy the chaos. Every day's different, right? So there's always new things. You're always challenged in new ways. And at AAON, we're not bogged down in all this crazy red tape that you see in a lot of these other places. So to me, it's very rewarding as an engineer, right? I spent 22 years leading engineering for our big applied stuff. And every day was different. You always had new challenges. It was never boring. And got a lot of great colleagues. Some of my best friends work at AAON. So I even met my wife at AAON. So
that's awesome.
It's very personal to a lot of us. There's a lot of us who's worked here a long time. So I guess that's what it means to me.
Awesome. Well, thank you so much for your time. We appreciate it. It has been very informative.
Yeah.
And to our audience, thank you for joining us. Stay informed. Go out there and talk to the authorities of your local government, and let's make sure that we move forward with this transition and make the best out of it.
Yeah. All right.
Awesome. Whitney, say bye.
Bye.